Welcome back, everyone. Here we are with another episode of the Midnight Sessions. Let's get started. Excellent. Let's talk now about the Cardano Tech Summit that took place a couple days ago in Rio de Janeiro, and the next one is gonna happen in Buenos Aires. So, let's first talk about what is the Cardano Tech Summit. So, Cardano Tech Summit, it's an event that it's been organized by Cardano community since long time ago. It happened once a year, and the last one that actually happened once a year was in last year, 2024. And since this year, 2025, something nice is taking place. Now the Cardano Summit, there's going to be a main event that's going to take place in Berlin this year. There's also regional events. And one of those regions, it's LATAM. So we have this Cardano Tech Summit LATAM, right? And in LATAM, we're going to have two events. One is going to take place in Rio de Janeiro, Brazil. And the other one, it's going to take place in Buenos Aires, Argentina. The one from Rio, I'm going to share with you some insights, feedbacks, and provide some extra context since it already took place and Edda Labs and Midnight participated in that event. I'm going to share with you some photos, some videos, and some nice things. And then I'm going to provide also some feedback of how it's going to take place the other Tech Summit in Buenos Aires that is going to take place only next month, November 15th. Okay, perfect. So let's talk first about Rio de Janeiro. So we have the venues here. So in Rio de Janeiro, the event took place in Museo de Amanhã. And that's an iconic place. I'm going to share with you some photos. And then if you want to see, the team is preparing some details about the venue and agenda for the Buenos Aires event. The organizer of this event, it's Ada Solar. And they're gonna do a really nice job in Buenos Aires regarding organizing this event. It was absolutely amazing to participate in these events. I mean, Ada Solar, they really know how to organize events. Okay, the agenda of the event in Rio, everything took place in one day. And it was divided in three kind of areas. One was kind of the panels that took place in the auditorium, and then we had workshops, and then we had the stands, the booth, where different projects showcased the products and gave some introductions. So the auditorium was pretty much focused on the governmental part, regulatory part, financial part, education part. The workshops, it's where the technical people, projects building an ecosystem, showcase the products, and they had a chance to have more time to explain how this technology works. And the booth, it's where like 8 projects in total showcase their products during the whole day. So in the auditorium, we can see that we had some keynotes from Caixa, which is a financial institution here in Brazil, really important one. It's a national institution, governmental institution. Then we had a stage regarding to government, transparency and innovation, blockchains at the service at the public sector. Then we had some keynotes from Cardano Foundation, some stage regarding education. We had the participation of PUC Rio, which is a really important institution and university here in Brazil. Some panels regarding tokenization, real world assets, ESG stage. And we also had a opportunity for some tech people to have a talk in this auditorium. We had the participation of TXPipe, Edda Labs, Exura, Andamio, Tabdano, and Ventry. So let's take a look here at the workshops. The workshop started with the presentation of the team of the Edda Labs team. I love the projects they are building, and they are focused on improving user and developer experience in the DeFi world. Then we had the participation of Edda Labs and Midnight. We gave some workshop regarding introduction to Midnight, how programmable privacy, identity and regulatory compliance works in Midnight. Then we had a workshop with TXPipe. They introduced the UTXO model, which is the model that works in Cardano. Then this work was really nice, Cardano ambassadors. So the organizers made sure to kind of gather together all the ambassadors in Latin America, and they did a workshop for the community. I have some videos I'm gonna show you to you later on. Then some products from the Brazilian community introduced their technology. One of them is Cardano. Then we had Binance crypto training class, some educational innovation in Cardano, with Render. This is a Argentina project, and they came to Rio to introduce their product. And then we had the participation of Andamio. Sebastian Pavon and Juanita came over to Rio de Janeiro. It was really nice to have them here. So, and at the end, it was some cultural presentations and VIP dinner. Really well organized events. Congrats to Ada Solar. So I'm gonna share with you some photos and videos regarding this event. So this is the venue of the event, Museo de Amanhã, a really iconic place. It was really well chosen. Here it's me and Taina from Edda Labs arriving to the Museo de Amanhã to get everything ready. We were with the Midnight t-shirts. We were introducing that technology to all the Brazilian communities. And here we have our first winner of the CK Poker game, right? For those that don't remember, I was sharing on Twitter and LinkedIn how this game is gonna work. The main idea was to connect three main pieces. One, education, the other one, entertainment, and rewards, right? We wanted to make sure people, with the limited time that we have during workshops and booth, to actually understand how Midnight works and kind of create that interest, so later on they can look for more information regarding CK circuits, privacy, and so on. So this game really fulfilled its purpose. So how it works? It's kind of poker, but it connects a lot of CK terminology. So we have this privacy part and we have the public part. The privacy part, you had to withdraw some cards randomly, right? And depending on your luck, you were going to be able to activate some circuits. So if you see here, the connection between the public and the private part are some proof that you have to send, right? It's just a representation. And these circuits, there are actually some constraints. If you were able to fulfill these constraints based on your luck withdrawing the cards, you were able to activate the function within that circuit. And those functions were pretty much increment by 1, 2, or 3, this counter in the middle represented by the Midnight logo. So each circuit was harder than the other, right? Depending on if you were able to increment by 1, 2, or 3, and depending on your luck on which circuit you were able to activate, you would win a bag, stickers, a hat, or a t-shirt. So Mauricio, he's a Cardano member from Chile that went all the way to Rio to participate of this event. He was our first winner to activate the circuit number 3, the most complex one, and he won the bag, stickers, t-shirts, and the hat. So we took a photo with him. he was really happy about it. Okay, what else? This is our second winners. So this is the team from Andamio. Really nice project. He's Sebastian, Juanita. They came all over from Colombia. Here's Taina, a member of Edda Labs. And here's Tom Humber from the growth team of the Midnight Foundation. So yeah, really happy that they participated and they won. What else? Well, this is the entrance during the event. So when people arrived, while registering, they could enjoy some samba, which is a Brazilian dance, really common here in Brazil, and enjoy some breakfast and do networking during that process. So I'm gonna share with you a video. What a really nice reception. People love it. People love it. Eating breakfast and working and watching people dancing samba. Perfect. I mean. So then we had the workshop that I mentioned, right? That we introduced Midnight, presented some use cases, and provide some instructions on how to get onboarded into Midnight, depending you're a developer or a business entrepreneur. So I'm gonna show you a video of the workshop. It was full house.
Então a gente fez uma batalha naval utilizando Midnight. Parece exemplo muito simples, mas é perfeito para a gente saber como funciona na prática Midnight. Cada jogador tem o seu board e precisa. Então a gente...
Oh, people were really interested on how this technology works. Here I share a video of Juanita, right, from Andamio. She was doing really nice interviews to people, and she did one here with Taina, and they talk everything about technology, Midnight, Cardano, and how women play a role in this ecosystem. So this was a really nice interview. It's in Spanish, so those one interested, it's on my Twitter, on my X. Here I have a video that shows how playful was this game, how people really got engaged while playing CK Poker of Midnight while learning how this technology works. I'm gonna show you how this worked out during the event. I really enjoyed watching this video all over and over again. I mean, it's really pleasing to see how learning can connect with entertainment at the same time, right? So there was really complex stuff explained during this game, but it's still people love it. You can see here that how many people were doing line to actually play the CK Poker game and win some swags from Midnight. I'm gonna share this video. See, here's the booth of Midnight. People were playing, were waiting in line to actually play the CK Poker game. They were really interested to understand how all this works. Here Ada Solder shares some videos summarizing the event. Here's the entrance that I just showed you, people dancing samba, and here's a workshop of the Cardano ambassadors. It was really nice to see all the ambassadors from Latin America gathering in one place, sharing their knowledge and experience.
Un sistema descentralizado en una infraestructura pública financiera para el futuro.
Really nice. Here I'm gonna show you a dance, which is a culture here in Brazil. That it's I mean, Brazil, they have a lot of cultures, and one of them is the condeira. And they presented their dance during the event. And for those that are not connecting still this culture, it's the same tribe that Charles Hoskinson went to when he traveled to Brazil, right, to experience these kind of the ants. You have these gloves that you put in your hands, and you have ants within those gloves that actually stung you, right? So this culture is this one, and they Edda Solar make sure to invite them over to the event to actually perform a dance. Really nice. I mean, this event was really well organized to Condeira. So you have this dance. I'm gonna share with you later other dance that were presented during the event. We had the participation of the Cardano Foundation. It was some closing keynotes. Here I have some other photos of the booth of Edda Labs at midnight. It was packed with people. I mean, people love CK game. You can see here we had students, members from different institutions, all playing the game while learning the midnight concepts. See, you can see here people trying their luck to win some swags. Also here, this is one of the panels that we had of education, government. It was led by Daniela. She's one of the Cardano, Cardano members in the Brazilian community, and she also is starting to participate in the midnight community. It was really nice panels. She moderated those panels. Here I have some photos of people winning, right, the CK poker game. You can see the smiles on their faces. Here are some students. You can see they enjoy playing the game. Here, people were so happy. Others, participants playing the game. Oh, he won a t-shirt. He was really happy to have activated circuit number 2. What else? This photo, he's a member from the Cardano community, an ambassador, and he actually watches these YouTube videos. So it was a really nice gesture, a really nice present that he gave to me during that day. It was actually the Professor's Day here in Brazil. So an apple represents kind of the fruit of professors. So he came over with an apple and gave it to me, since he and others consider me a teacher, a professor. So I was really happy, and it is a privilege to actually share knowledge and gain knowledge with others. So we have this photo here. And during the closing, we had this other dance, which is a capoeira. It was really impressive to watch, and I wanted to share with you guys. I'm gonna put it here. I mean, really impressive. So I wanted to share with you guys the quality of the dance and culture that it was shared by the organizers, Edda Solar. Okay, so that's regarding the event in Rio. The next one coming, it's the one from in Buenos Aires. And Edda Solar share some insights regarding that event. I really recommend for those that are going to be able to attend, to register and go. It's going to be really nice. This one, it's actually they're gonna have the main event, which is gonna take place on November 15th. But actually, we're gonna have some free courses, hackathons, and some kind of surprises that are gonna take during all this event. So they mentioned here that during November 3rd to 13th, there is going to be a free smart contract training. So those ones that really want to understand how Icon works, how to write, how to develop a smart contract, this is your chance. This is going to be led by the IOHK education team, so you cannot miss that. Then we're going to have some hackathon prizes that is going to take during November 14th and 15th. So it's really well connected. You're going to be provided with the training, and then with that knowledge, you're going to be able to participate on hackathons. After that, we're going to have the main event, right? We're going to have workshops, panels, and also the presentation of the winners of the hackathons. We're going to have some Japanese culture as well: taiko, kendo, aikido, chess, networking and community, and also free food, merch, and surprises. So anyone that is interested, here are the links. You can go to the post of Edda Solar, and they provide the links here to register and some infos regarding that event. So if you are going to be able to make it, or if you are around in Argentina during that time, this is something that you cannot miss. Okay, perfect. So let's return to the contract part, how to write smart contracts, and just doing a summary of what we learned during the last 16 sessions. We started working with a really simple contract, which is called the counter contract, but we learned how to connect all the parts within the midnight architecture. And by parts, I mean how to write contracts, how to write the CLI part, the API part, the UI part, different testing frameworks, how to connect the providers, how to do deployment. So we put everything together just to get a grasp of how the whole midnight architecture actually works and gets connected. But now, since we already have that foundation, what we're going to learn is more complex contracts and get deeper into some technical concepts, right? So right now, we are going to start with the bulletin contract, which is everybody that starts learning in Midnight, I mean, they have to go through the first two most basic contracts. One, it's the counter contract, and the other one, it's the bulletin contract. So we have already learned the first one. So now we're going to start with the second one, which is interesting with this second contract is that we actually going to use some private information. So it's still a really simple contract, but now we're going to understand how this private information gets connected to contracts and how we build CK, zero knowledge, to actually interact with that private information and the public information. Perfect. So we are going to use the same repo from the mesh organization, which is called midnight contracts, right? And we're going to be on this file regarding the second contract, which is the bulletin board. Remembering that under this repo midnight contracts, we are writing different contracts using compact, now called Minokawa, right? But now we're going to understand this bulletin board. So under this file, we're going to go to the file with extension .compact, and we're going to study this contract here. Okay, let's start by understanding these two first lines. It should be familiar to most of you if you have already watched the first 16 sessions. The first line, it's we are actually declaring what is the version of compact or Minokawa we are using. In this case, we are using version 0.17. So we do that by calling pragma language version, and then we pass the actual version of the language. In this case, 0.17. There is a new version, 0.18, that it was just released this week. But for this contract, we don't need those extra new features. So it's okay if we work with version 0.17. 0.18, it actually improved the handling of arrays. So we can better create and interact with different elements within an array, a bat array. Okay, but since we are not gonna need that features, we are okay to work on 0.17. Nevertheless, we will upgrade during, if it's not this week, next week, we're gonna upgrade all these contracts to the newest version, which is 0.18. Okay, second line, import compact standard library. This is a library that it's being already built by the Midnight team that is gonna give us some structs and some circuits that we can use, so we don't have to recreate different functionalities from scratch. What are the functions and structs available under this library? To answer that, we can go to the docs, which is gonna be our best friend, right? And we have here the compact standard library documentation. If we click here, we can see here the list of different structs that we have available under this standard library and some circuits, right? So we're gonna have all these in our power to use when writing smart contracts. Okay, then we're gonna declare a custom type. In compact or Minokawa, we have different ways to declare custom types. One, it's by using this command enum, and there's another one called struct. If you just take a look here at the documentation of the standard library, I just show you that you have circuits and you have structs. So this struct it's the other way to actually create custom types. In this case, we're gonna use the enums way. Why? Because we don't need to create complex types. We just need to list different options that our type is gonna have. So in this case, the enum state, it's gonna have two states, right? Two levels. One, it's vacant, and the other one, it's occupied. That's it. The type state can have two values, vacant or occupied. And then we declare the different variables under the ledger type, right? Export, ledger, and the name of the variable and the types. This ledger, it works pretty much similar to a normal Web 2 application with databases, right? Before going through the declarations of the ledger variables, we first need to understand what is the purpose, what is the objective of our application, so we can then design how it's going to be the structure of our information. So in the case of Web 2 applications, the data is going to be stored on a database. So we have to understand how this data is going to be structured so we can define that database types. In the case of Web 3 blockchain, the application logic is the same, and the data is going to be stored on the ledger of the blockchain. So in this case, it acts pretty much similar as Web 2 applications. So we need to first answer the first question. We mentioned that we're going to use this bulletin contract. But what this contract it's actually doing? Okay, so this bulletin board, it's really simple. Think of a board which is empty, right? And any user can post a, let's call it a sticky note, for example. If the board is empty, anybody can post a sticky note. If somebody else has already posted a sticky note, nobody can take that post out and post their own, right? The only person authorized to take the post down is the same user that actually posted. Okay, so that's rule number one. And rule number two, it's that the only person. So the first one, it's empty, and you can post it once. The second one, it's only you, the owner of the post of the sticky note, can post, can take it down, right? So that's where we start using the private part, because one function, one utility of this contract, it's to actually post a sticky note, but without revealing who you are. And then when you want to take it down, you're going to be able to demonstrate that you are the owner without disclosing any private information. So in simple terms, you can post a sticky note, you can take it down, and you can demonstrate that you are the owner without disclosing the private information. Perfect. So now let's declare the ledger variables that we're going to use to store public information in a way that we can accomplish this specific use case. So we have a ledger variable called state that is going to be of type state that we just mentioned. We have state and occupied. So this is going to represent the state of our board. It's either empty or it has a sticky note on it. Then we have the message. So that represents the message that it's written on the sticky note. So it's going to be a opaque string with a wrapper called maybe. So let's first answer what is this opaque string. So a string, it's what we know, it's just a string, and the opaque, it's a way to say to the circuits that we are not interested on using the data within the string to calculate or to do some logic within our circuits. We just want to store the string as it is, as a blob, and then retrieve it as a blob. So we don't care what's inside. So in that way, our circuits are much lightweight. So that's why we use this opaque string. And then we have a wrapper called maybe. And maybe, by its name, it's pretty obvious. It either has a value or it doesn't have a value. So how do I know I have this maybe struct? So remember that we're using this library called compact standard library. So let's take a look here. If we go to the docs API reference, we can see here that we have an struct available in the standard library called maybe. If I click on maybe, we can see that we already have an struct defined. And this maybe, it has a property of isSum, and it's of type Boolean, yes, true or false, and a value of type T that it's passed when the struct is created. So this maybe, you can have a value if the Boolean is true. Perfect. So we're using this struct maybe to say that we might have a message or we don't have a message. Then we have an instance of type counter, and this counter, it's an ADT type. What's an ADT? ADT are types that we can use to declare our ledger to avoid contention. If different users create transactions that interact and they want to change the state of our ledger variables, we might get into contention, right? So these ADT types are created in a way to avoid concurrency. So different users can interact and the state's gonna be changed in a way to avoid one of the transactions of one of those users to be blocked. So it's really important to use this ADT. So where we can see the ADT available in Compact, we have here ledger data types, and we have all these available for us to use. In this case, we're using counter. So counter, it's an ADT, it's a simple counter, and you have different methods. Okay. Then we have a poster and a poster public key. A poster is of type bytes32, and poster pub key is of type cswap coin public key. So bytes32, it's a compact type. How do I know it's a compact type? So let's take a look here, compact reference, and we can see here all the built-in primitive types available. We have Boolean, uint, field, arrays, vectors, and bytes. So we're defining a bytes at 32 bytes. And cswap coin public key. What type? What is the structure of this type? Well, we can go back to the documentation's standard library, and we can see here that we have an struct called cswap coin public key. If we click on that, we can see that it's a wrapper of type bytes32. So it's an object, the property bytes of type bytes32. Perfect, so it's actually bytes32, but this one, it's a property already known within the Midnight blockchain. And it's bytes32, it's more a general one, something that we want to represent as bytes32. Later on, we're going to understand when to use poster and poster public key. Excellent, so now we have already declared the different data that we're going to define within our construct. Now we have this instruction that starts with constructor. So everything that's within constructor, it's going to be run once we deploy our contract. And no more, right? So it's only executed once. Then when we execute circuits, this constructor is not going to be run anymore. It only runs one time in its life cycle during deployment. So let's understand what are the instructions that are going to be run during the deployment of this construct. The first one, we are initializing the variable state of type state with the value state. That's the way we can access a enum and attribute a value. So we access the state point, we access the values here, and we are assigning the value vacant. So something really important to mention here is that all these ledger variables, they have some default values. So if you don't declare any or don't initialize any value to these ledger variables, a default value is going to be assigned. In this case, for the enums types, what is the default value? Is the first element of the enum. So in this case, it's vacant. So in this case, if we omit this instruction, our contract is going to behave in the same way. The reason the author is including this instruction here is for clarity. So we're making sure that everybody that reads this contract understand that the initial value of a state is vacant, right? The board is going to be empty. Perfect. Second instruction, we are initializing the variable message of type maybe. So how do we declare, how do we initialize a variable of type maybe? We are using the circuit none. How do I know that we have available that circuit? Okay, again, always remembering that we have this standard library. So we go back to our best friend and we go to the documentations of the compact library. And here we can see under circuits, we have a circuit called none. If we click on that, we can see here that it's a circuit that outputs a value of type maybe. So that's what we want. We want something that creates a value of type maybe. In this case, this none, it creates a type maybe containing nothing. And that's what we want. We want to initialize a value of maybe without any value, nothing. Perfect. So we're going to use none and pass in the type opaque string. Why? Because the message of it's of type maybe with this type. So to create that value, we pass none and pass that type and we close it. Perfect. Now message has a value of type maybe, an opaque string with nothing. The third instruction, we have instance. Instance is of type counter. It's an ADT. So it has some methods on it. How do I know the methods? Again, we go to the ledger data types, the meta documentation, and we're gonna see that we have this ADT called counter, and we have some methods. And the method that we're using is increment. So we're gonna increment by an amount of type uint16, and that's it. So we are incrementing the instance by 1. So what happens if we remove this instruction? This instance is of type counter, and the default value is 0. So if we don't put this instruction here, after deployment, the instance value is going to be 0. But because within the constructor, during the deployment, we're going to actually increment by 1 that value, after deployment, the instance is going to be 1. Excellent. So now we have this new instruction that starts with witness. So that's the way we declare our witnesses, right? Functions that are gonna be declared off chain. So in the compact contract, what we actually declare is just the name of the function, the arguments that are gonna be passed to that function, and the output type of that function. But the implementation itself, it's declared off-chain. Where is that off-chain it's gonna live? In this case, we have this file called witness.ts, it's TypeScript. And here we have the implementation of our function local secret key, which is this local secret key. Okay, let's understand just the macro of this implementation. Later on, we're gonna go much deeper and understand its structure. So we are not passing any arguments, and we want this byte 32 as an output of the implementation. So this witness, here we are declaring the type of our private information. This second, it's a function that creates a value of this private information type. And then here we declare the witness implementation. So here in this witness, it's an object that is going to declare the different private functions that we declare in the contract. In this case, we only have one function. So we are declaring just this one function. And then we're passing this type constructor and passing the types of the ledger, the private information. As an output, I'm going to have two things. One, it's the new state. So when we execute circuits, we actually change the state of the ledger. But also, we can change the state of our private information. So in this first part, we declare the new type if we want the private information to actually change. If we don't want to change, we just keep it as it is. And in this second part, we declare the output of the contract declaration. So if we remember, if we go back here to the contract, we can see here that the contract is expecting a byte 32. So that's where we put here, uint 8 array. Okay, I know somebody would be questioning himself, like, Eric, you just mentioned byte 32 and now you're saying uint 8 array. There are different types. So what's going on? Okay, that's true. One, it's the compact type, and this one, it's TypeScript type. How do we know the compatibility between compact and TypeScript types? So once we compile our contracts, this file is created, index.d.cts. And here it's the TypeScript implementation declarations of the different types. So in this case, we have this witness, the function local secret key, and as an output, you can see you have a private information of type T, since for the compact contract, it's opaque, the implementation of the private information. They use the variable T as a representation. And this one, it's the output of the function, which is byte 32. In this case, it's being represented in TypeScript as uint 8 array. Perfect. So I now know that byte 32 it's represented as uint 8 array. That's why here in the declaration I'm putting uint 8 array. Excellent. Well, later on we're gonna understand all this implementation, but just this was intended to provide a macro understanding of the implementation of the private information. Excellent. So we have this witness called local secret key, and now we declare the circuits. So in this case, we're gonna have three circuits. One is post, the other one is takedown, and the other one is public key. the circuits post and takedown, I think it's pretty obvious what is the purpose of those circuits, but these circuits are impure, and the public key, it's a pure circuit. What is the difference between a pure and impure circuit? A pure circuit, it doesn't handle with public or private information. Impure circuits, they do handle with either public or private information. So that's why it's called pure, right? It doesn't have any effects. It just have inputs and outputs. So if you see here, for example, this is a pure circuit elaborated on the standard library, and we're using these circuits to actually execute some stuff. In this case, this public key, you can see that we're using that circuit within the post and takedown circuits to do some things, right? So you can see that circuits are like functions. You can declare functions and use it within other functions, but in this case, they are also circuits. So you, once compile, you actually create some cryptographic material necessary for the circuits to be implemented. Okay, perfect. So let's understand first what this public key circuit actually does. So in this case, it's a circuit called public key, and we are passing two arguments. One, it's a secret key of type bytes 32, and there is an instance of type bytes 32. Perfect. Secret key bytes 32. I think we can already connect it with this local secret key. You can see we are going to have some private information of type bytes 32, and we can use that as an input to this argument. Perfect. And they have this the same type. Instance bytes 32. If we remember, we have a ledger variable called instance as well. So we have this instance of type counter, but counter is not the same type as bytes 32. In Compact, we have a way to change types, to cast types. So we're gonna later on learn how to pass a type counter to bytes 32. And the output of this function, we want it to be bytes 32. Okay, let's see the implementation and understand what this circuit, pure circuit, it's actually doing. So we're gonna use the other circuit called persistent hash. So another question, where is that circuit being implemented? Okay, we have the standard library. So maybe that circuit is implemented under that library. Let's take a look. So if we go to the standard library, we can see that we have circuits available. And one of those circuits, it's called persistent hash. Okay, so that was implemented for us. And what it's doing, it's actually implemented the SHA-256 compression algorithm. So it's the hashing. So what we are doing is passing a value of type compact type, and it's returning a bytes 32. What is a compact type, right? Just remember here, we go to compact reference, we have all these compact types. So we have Boolean, we have uints, we have field, we have arrays of types, it's tuples, we have vectors, bytes, and opaque, right? And we learned that we just use the opaque of type string. We also have opaque of type uint 8 array. Okay, excellent. So we know that we're going to use persistent hash and we're going to pass a compact type. What is this compact type right now? It's a vector of 3 elements of type 32, right? Just remembering that we took a look at this type vector. So we have this built-in type vector. We pass the number of elements of type t. So in this case, we have vector, 3 elements of type byte 32. So what are going to be those 3 elements? Well, I think it's kind of obvious that 2 of them is going to be the secret key and the instance of type bytes 32. So we're passing those 2 here, instance and secret key. And we have a third one. What is this path doing? A path is a way as well to create bytes in compact. In this case, we are passing a 32 bytes and we are initializing it with this string, bulletin board pub key. the purpose of this is to create a salt. What is a salt for? It's to avoid replication. So if we deploy 2 contracts, we might use the same instance and secret key at one point. But if we initialize each contract with a different salt, in that case, we are never gonna have any replication. Perfect. So this public key, it's pretty much doing a hash of 2 values, secret key and an instance, that we're gonna use for implementing the circuits post and takedown. Excellent. So we have learned new concepts when writing smart contracts, how to actually implement the witness, and how the difference between impure and pure circuits. For the next session, we're gonna learn how to implement these post and takedown circuits and understand in a more thorough way the implementation of the private information here. Excellent. Well, so that was pretty simple. We're gonna run as well these contracts later on to actually create all this material regarding the compiler. You can see here that we have the managed bulletin board, which is the output after the compilation. Then we're gonna have the compiler, the contract material, and the CKIR's implementation. But we're gonna take a look on that on the next episode. Okay, perfect. Now regarding question and answers, we're gonna go through the Midnight forum and community board, as we mentioned in the last session. These are gonna be the 2 platforms that we're gonna take a look at to see the questions and feedbacks from the community. So regarding the forum, we have it here open. We're gonna take a look at the last topics that are related to what we are discussing right now within the sessions, and take a look at that. Okay, let's see the last 7 days of questions. We have one here of Boshako, strategies for masking asset owners. That's a really hot topic, and we have seen one way to do it right now in the bulletin contract using hashes. So let's take a look here on some ways the author here is mentioning, right? So we have this first option. We have a local secret key with bytes 32. We have a assets representation with a map and some joint 128 that represents, I think, the token ID, and some bytes 32, which is the owner, right? So we have the local secret key, we have the asset ID, right? And this circuit called generate owner ID. So what is this circuit doing? If we take a look here down, we can see that we are passing the secret key and the asset ID, and we are using this circuit from the standard library called persistent hash. So it's a hash, pretty much the same procedure that we were doing with the bulletin board, right? So we are calculating the hash of a salt, a secret key, and an asset ID. The second option here, it's doing the same circuit, but instead of passing a secret key, it's using a own public key that gets a C-swap coin public key. So depending on the implementation, this procedure here, we are using something that it's known to other people, right? So it's more like a hashing of something that other people might guess, because this C-swap coin public key is something obtained with the wallet, right? So if somebody knows your own public key, he can grab that key and calculate that hash and see if the generated owner ID hash it's the same, right? With this first procedure, it's much better because nobody can guess this local secret key since it's only known by you. And then down here, they're mentioning something about the midnight.meshjs.dev package function from the wallet SDK package of the Midnight wallet libraries. And this implementation is something nice, since you see here that we're using pure circuits, generate owner ID, and we are passing this bytes pub key. which is kind of the wrapper of a CSwap coin public key. So the author here is trying to get this pub key from the output of the wallet providers. So how do we transform? How do we make it compatible? So they're using these two functions, midnight page 32 and the encode coin public key. So this is nice. So we're getting the coin public key, then we are parsing using this midnight page 32 to get the page 32M, and then passing to hex. And once we have the hex after parsing, we are gonna encode it to make it compatible with bytes, right? So in that way, now we can pass it to the circuit and run what we want. So this is something nice, right? That we're using encode coin public key and the midnight page 32 to parse it. Perfect. What else? We have some midnight airdrop regarding that topic. Today it's the last day. Actually, we have 24 hours. Tomorrow is the last day. We are Sunday right now. Monday, it closes. So hurry up if you haven't done it yet. Then we have some wallet entropy using bit39. A lace extension. So we have a library for that. It's a dApp connector API. Midnight Kitties. This is a contract that was released and included in the awesome dApps within the Midnight repos. We are taking a look right now at two contracts, which is the counter in the bulletin board. Later on, we're gonna study other more complex contracts as this one, Midnight Kitties. We have the Midnight setup. This is one of the packages and libraries just released from the Mesh team. Luis is working on that. So it's an abstraction. So developers, they don't have to compile the contracts themselves. They don't have to worry about the templates, and they just need to worry about using the APIs and interact with the contracts using APIs. So this library, it's nice. I recommend you guys to use it, so you don't have to deal with all the boilerplates and compilers. What else? We have a new community led Midnight Explorer. I have it here open, so you can see that now we can see some transaction hash blocks from the Midnight network on testnet. So this is nice. Then what I'm trying to claim, this is regarding the claim process, midnight.js 2.1. So this midnight.js 2.1, it's the new release of the midnight.js package. And as I mentioned before, regarding Compact Minokawa, we have a new version, 0.18, which adds features regarding timing in Compact. And midnight.js 2.1, it's the new release that handles timing for handling those new features within the Compact contracts. So in later sessions, we're gonna take a look at that as well. Then we have some Midnight Explorers. This is the Midnight package that I just mentioned from Mesh, Midnight setup. We have some more information here of people using it, what it's the benefits. So it's an abstraction, so you don't have to deal with boilerplate and compilation. Then we have some ledger. Well, that's the main topics regarding the forum. So I really recommend taking a look at this new repo, Mesh SDK Midnight setup. Regarding the bulletin boards, the community boards, we have these triage, right, that we were discussing the last time. When you create an issue, it starts with no status, and then depending on some analysis, it's gonna pass to rejected or need discussions. If discussions and voting takes place within the constraints, this task can pass to another board, which is the grab and go board. All issues that are under this board, they are executed, they are implemented. So we can see here that one task was already implemented, which is getting a started section, install, create Midnight app, more to come. We have another task here open, which is getting started section. I think this one was completed already, and they're gonna merge it since today during the fireside hangs they introduced and presented the new docs regarding this aspect. If we take a look at the docs here, we can see here at the getting started, this has changed, and now we have these 4 sections: installation, create a Midnight app, deploy, and interact. So there were some feedback regarding documentation of developers wanted to understand how to create from zero a application when it comes to installations, create a contract, a really simple contract, but create a contract, deploy that contract, and interact without having any boilerplate, just everything from zero to actually deployment. So they created this procedure, and during the fireside they went step by step on how to perform this implementation. So I think this was already done. And then we have some Midnight DApp architecture infographic. So this is something that hasn't been assigned to anybody yet. So I guess anybody can come over and see I can do this. And this is a really nice topic because infographic, it's a really nice way to explain how Midnight works, right? So these are tasks that are ready to be implemented. Grab and go board. And the community board, during the next sessions, we're gonna go through some of these issues that are under need discussions to actually take a look of what the community is asking, what is the status, and provide some answers and some voting as well. Remembering that this task pass the triage and go to the grab and go if discussions are set and completed, and also there's a lot of people voting on those issues, which means there's a lot of people that really want those issues to be implemented. Thanks everyone for joining another Midnight session. It was great learning together. See you in the next episode. Bye bye.